So here's the story with reference angles. Today, we're only going to find them. Tomorrow, we're going to use them. So today, you're going to be like, why am I doing this? I'm not actually doing anything with it. Tomorrow, you'll be able to use them. It's just too much to do in one day. Basically, instead of having to find trig functions of every single angle between 0 and 360 degrees or 0 and 2 pi, we can just boil it all down and only find trig functions between 0 and 90 degrees, and then use what we know about the four quadrants and where things are positive and negative, and do a fourth of the work and then just change it to positive or negative instead of doing 4 times the work. So that's what we're going to be doing today, is we are going to be finding reference angles. So reference angles are, we take angles that are in quadrants 2, 3, or 4, and we find a new angle to use instead of that angle that's in quadrant 2, 3, and 4. So here's the definition of a reference angle. A reference angle is when we let theta be a non-acute angle in standard position that lies in a quadrant. So far what that means is that it's non-acute, which means it's not between 0 and 90. Because if it's between 0 and 90, it's in quadrant 1. Don't find a reference angle, just use the angle. Standard position means it starts at our positive x-axis and then goes counterclockwise. I don't know how to read a clock. Counterclockwise. And then lies in a quadrant means that it is inside one of the 4 quadrants and it's not on one of our 4 axes. So it's not at exactly 90 or 180 or 270 or 360. So if we have an angle that is inside basically quadrants 3, 4, or 2, 3, or 4, I don't know why I said it like that, and quadrants 2, 3, or 4, then its reference angle, so that's what we're going to be finding today, its reference angle is the positive acute angle. So positive, we know what that means. Acute means less than 90 degrees, so between 0 and 90. And then we are going to label this angle theta prime. So that's going to be a theta with a apostrophe. Theta prime formed by the terminal side of theta and the x-axis. That is your definition of a reference angle. So for any angle that's not acute in standard position, and it's also not on one of our axes, your reference angle is the positive acute angle theta prime formed by the terminal side of theta, so where the angle is, and the x-axis. So depending on what quadrant you're in, you're going to use a little bit different of a rule to find each reference angle. Okay, we're going to do one example for each quadrant, and then one example, so that's going to be quadrant 2, 3, 4, so that's 3 examples. And then we're going to do one example if you are not between 0 and 360, because then you have to find a coterminal angle and then find the reference angle of that angle. So that is the plan for today. We're going to start out with quadrant 2. So the first thing that I want to do is I want to draw a picture and give you a rule. So I'm going to draw quadrant 2. I was about to say that quadrant 2 is my favorite quadrant. It's not.
What is your favorite?
I think quadrant 4. I think quadrant 4 is real fun because those tangents become positive because two negatives make a positive when dividing. I think that's real spooky. Okay, so in good old quadrant 2. So I'm going to label this Q2. I'm also going to write down that this means that 90 degrees is less than x, or theta, sorry, is less than 180 degrees. And then I'm also going to label where this would be in radians. So in radians, this would be between pi over 2 and pi. So pi over 2 is less than theta is less than pi. Okay, so in quadrant 2, let's say that we have an angle in quadrant 2. I'm just going to draw a random line here. My original angle would be from my positive x-axis to this line, and that would be my theta. Instead of using that theta, which is going to be between 90 and 180 degrees, or pi over 2 and pi, we are going to find this little angle right here, this little guy. So that's the distance, the positive acute angle formed by the terminal side of theta and the x-axis. So it's going to be this angle in here, and that is going to be our theta prime. So, just using our understanding of angles, from here all the way to here, how many degrees would that be?
180.
180. So to find this angle, we just take 180 and we subtract the red theta to find our theta prime. And then that theta prime is our reference angle. So to find a reference angle in quadrant 2, your rule is that for degrees, theta prime equals 180 degrees minus theta. And then the exact same rule in radians would be that theta prime equals pi minus theta. Because pi and 180 are the same thing. So those are our rules if we are in quadrant 2. And we're going to have a different rule for quadrant 3 and a different rule for quadrant 4. But that is our rule for quadrant 2. Okay, so that's our rule. I'm going to do my example over here. So our first example, and on your assignment, you guys are going to have to figure out what quadrant things are in. I'm telling you because we're doing them with the rules. So our first example is going to be to find the reference angle of theta equals 5 pi over 6. So basically our red would be 5 pi over 6. We're trying to find the green. So 5 pi over 6 plus what gets us all the way to 180 degrees? Or you know 180 degrees minus 5 pi over 6. We're actually going to do pi minus 5 pi over 6. So we identify that we're in quadrant 2, because 5 pi over 6 is in quadrant 2. Then we identify that we need to use this rule because we're in radians, and we say that theta prime equals pi minus 5 pi over 6. And then we've just got to do that math. Mason and Jalen, can you put your noses away, please? Huh? Can you put your nose away, please? Thanks. Okay, so then we can multiply by 6 over 6 to get ourselves one of those common denominators. And we'll do 6 pi over 6 minus 5 pi over 6. And we'll get that theta prime equals pi over 6. You could also save yourself some time, and instead of getting a common denominator, ask yourself the question, how far away is 5 pi over 6 from pi, which would be 6 pi over 6? So one singular pi over 6. Okay, so these are the rules, not this, these are the rules we use if our angle is in quadrant 2, and there is an example of quadrant 2. Any questions about reference angles or reference angles in quadrant 2? Okay, Jalen, Jordan, Mason, pay attention. Okay, I'm waiting for you, though, to be ready to move on. So this goes two ways. All right, so next thing we're going to look at is quadrant 3. So quadrant 3, which we have now decided is my favorite quadrant, just now. No, I picked quadrant 3 because I like the double negative.
Yeah.
Oh, well, I meant 3. This entire time I meant 3. Okay. All right, so yeah, no. Tangent's positive in quadrant 3. You silly goose. All right. So an angle in quadrant 4 would be here-ish. Our standard form angle would start here and go all the way around to there. So it would be between 180 and 270. So that would be my theta. In red would be between 180 and 270. We are going to be finding our reference angle. Your reference angle is always the angle formed by the terminal side and the x-axis. This time, that means our reference angle is going to be this guy here. So that's going to be our theta prime, is from the angle back to the x-axis. So this angle is in quadrant 3. We are in between, in degrees, we're in between 180. So 180 degrees is less than theta, is less than 270 degrees. In radians, that would be between pi and 3 pi over 2. So pi is less than theta is less than 3 pi's over 2. So that's where we are. And that's where we're going to find our reference angle. Okay. So now, if those two little green lines I drew, that's where we need to find our reference angle, right here. How do we use this angle? How does my entire theta compare to my little theta prime? What's going to be the difference there?
Theta minus 180.
Yeah. So we're going to take our entire angle, and then we're going to take off this 180, and this little guy left. So our theta prime is theta minus 180. So theta prime is theta minus 180, or in radians, theta prime would be theta minus pi. So it's kind of the opposite of when you're in quadrant 2. Because when you're in quadrant 2, you're below 180, so you do 180 minus. In quadrant 3, you're above 180, so you do minus 180. So basically, you're just trying to use that 180 to get back to 180 degrees. So in this one, you know you're going to be less than 180 degrees, so it's 180 minus. And this one, you know you're going to be more than 180 degrees, so it's minus 180. So that is our rule for good old quadrant 3. Which we have now decided is my favorite quadrant. Maybe. Okay. Our second example, we're going to do an easy one. We're going to do a degrees one. We're going to find the reference angle of theta equals 225 degrees. So literally all we have to do is plug in theta, subtract 180. So theta prime equals 225 degrees minus 180 degrees. 225 minus 180 is 45. Theta prime equals 45 degrees. So basically you're asking yourself, a 225 degree angle, how far away is that from the positive or the negative x-axis, which is 180 degrees? Yeah, we just have to learn one more rule for quadrant 4. All we're doing is finding an acute angle in between the x-axis and the end of our original angle. So we're finding reference angles. Yes, and then we'll use what we know about where sine, cosine, and tangent are positive and negative, so that we'll use it tomorrow. So that way, instead of having to do trig functions between 0 and 360 degrees, you only have to do trig functions between 0 and 90, basically. Boiling it down. All right. Any questions about our second example and quadrant 3? Okay, we're going to head to what turns out not my favorite quadrant, but I may have mistakenly said was my favorite quadrant, which is good old quadrant 4. So, in quadrant 4, that's my bottom right-hand quadrant. If I had an angle in quadrant 4 in standard form, I'm going to put it there. It would start at 0, and it would go all the way around to here. That would be my theta, which is going to be a really big angle. Instead of using that angle, we want to use this little guy, theta prime. So from the positive x-axis down to where my angle ended. We would use 360. So let's first talk about where this is. We know that we are in quadrant 4 because I just told you that. And also, looky look. Quadrant 4, so that means we're between 270 degrees and 270 is less than theta is less than 360. In radians, that would be between 3 pi over 2 and 2 pi. So 3 pi over 2 less than theta less than 2 pi. Okay, so if we know that from here all the way, so theta and theta prime together would be a whole circle, would be 360 degrees. So then we can just do 360 minus this whole big guy will be that little guy. So that is our rule. Yes, we use 360. So our rule is that theta prime equals 360 degrees minus theta, or in radians, it would be theta prime equals 2 pi minus theta. Okay, we're going to do an example of this one, and then we're going to do one example where it's a coterminal angle, and you guys will have a little bit of time to work today, but again, remember I'm giving you a work day on Wednesday. So, example number 3, we're going to find a reference angle for 345. So for 345 degrees, we would just take that 360 minus 345. So theta prime equals 360 degrees minus 345 degrees. So that's just going to be 15 degrees, which makes sense. That 345 degrees, and then go 15 more, we take you back to 0. Back all the way around your circle. Okay. Any questions right now? Okay, so you've got 3 rules, depending on, you don't need a rule for quadrant 1. If you're in quadrant 1, you don't find a reference angle because you're in quadrant 1. You're already between 0 and 90. Last thing is, if you are not between 0 and 360, and you are either like below 0 or greater than 360 or greater than 2 pi, you are going to need to find a coterminal angle and then find the reference angle of that. So last example we're going to do, we're going to find the reference angle of theta equals 8 pi over 3. So theta equals 8 pi over 3. So 8 pi over 3 is above 2 pi. I know that because 6 pi over 3 would be 2 pi. So step 1 in this is to find a coterminal angle. So that's your step 1. So we're going to take that 8 pi over 3, and we are going to subtract 360 degrees, or in radians, that would be 2 pi. To get 2 pi to have a denominator of 3, we would multiply by 3 over 3. That would be 8 pi over 3 minus 6 pi over 3, which would be 2 pi over 3. Okay. So that's what we did in 5.1 B or C, finding a coterminal angle. Any questions about finding the coterminal angle? Okay. Then we've got to use our big brains to figure out what quadrant that is in, which is something you're going to have to do on your assignment anyway. What quadrant would 2 pi over 3 be in? 2, because 2 pi over 3 would be 2/3 of the top half of my circle, so it would be in quadrant 2. So, second step is going to be to find our reference angle. The reason why you have to figure out the quadrant is because you need to know what rule to use. So in quadrant 2, the rule we use for radians is that theta prime equals pi minus theta. So theta prime equals pi minus theta. So now we can do pi minus 2 pi over 3. So theta prime equals pi minus 2 pi over 3. You can either multiply by 3 over 3, and they get 3 pi over 3 minus 2 pi over 3. Or you can say to yourself, how far away from a whole pi is 2/3 of a pi? 1/3 of a pi. What do I need to add to this to get it to be a whole? So, anywho, 3 pi over 3 minus 2 pi over 3. And eventually we'll get to theta prime. Oh, I'm off the screen here. Theta prime equals pi over 3. Cool. Questions, concerns, emotions, thoughts about this? Okay, you have 10 minutes to get started on your assignment. I bet you can get halfway through the ones where you're just finding the reference angle and you don't have to find the coterminal yet. Get started with your assignment today because it'll make tomorrow make a lot more sense if you've like started to apply the finding of reference angles today. But then if you don't get done, don't freak out because you'll have a work day on Wednesday. But get started. I'm going to stop this recording. Bye, recording. Been nice knowing you.